And live.
Hey, we're back. We are back. If you were with us a couple hours ago, about an hour ago, we did the Ranger and Explorer class safety inspection tutorial. And now we're back for the Explorer class prop demonstration and Q&A. I'm Jill Zande. I'm the Associate Director of the Mate Center and Competition Coordinator, and I'm here with Competition Technical Manager Matt Gardner and special guest Scott Frazier. He's our lead safety inspector. That's his volunteer job. His day job is as the Electrical Technology Department Chair at Long Beach City College. And speaking of Long Beach City College, Scott just informed me that one of the Philadelphia Eagles team members played at Long Beach City College, Brian Brayman, and he was just there the other day.
That's right. I'm sorry you missed it.
So I had to look up his great play, many of his great plays during the Super Bowl, including that last one. There was a bit of trickery going on, and he made the tackle. I'm sure you all saw that. I know Matt did.
But I was going to say, I am also a Long Beach City College graduate. I have successful completion of Daycare 1 and successful completion of Daycare 2 at Long Beach City College.
But Matt does not play for the Philadelphia Eagles, and he's not Brian Brayman. But anyway, back, we're going to stop talking about football eventually.
Maybe.
Anyway, so now we are back again. Facebook Live in it. Just a reminder, hit the subscribe button so you don't miss us when we go live again. We have moved out of the CMate workshop and we're in one of the lecture forum rooms in the lecture forum building. Hopefully the lighting's okay and the acoustics are good. And now I'm going to turn it over to Matt and to Scott to work us through the Explorer class mission props.
Okay, hi. As I said, I'm Matt from the Mate Center, and I'm one of the people who helps design, come up with these missions. And then I'm also the one who usually turns whatever missions we come up with into the PVC or milk crate props that we have. So today, what I'm going to do is I'm going to run through the missions for the Explorer class props and tasks. If you have questions, of course, as always, write them in and Jill will see them. Flag me down, wave, let me know, and we'll try and answer all of your questions. So we're going to jump right in for the order of tasks. I'm going to go through them in order just to keep it as is in the manual. But at the end, I'm going to talk a little bit more about the order you can do the task, including a hint for all the teams out there, which isn't much of a hint since I've given it to both Scout, Navigator, and all the Ranger teams before. But so stay tuned for that, okay? So we're going to start with Task 1. Aircraft, and this one pretty much has to be done in order. So the first thing you're going to have to do is you're going to have to do the math. So you are going to get some flight information. So you'll get a sheet just like this, and actually this is the data from the manual. So you're going to get something like this. It'll probably be laminated since the sides of pools are wet, and it has all the information you need. And then you're going to have to figure out from this information where the airplane went and where it crashed into Lake Washington. So I have it set up, and I do want to say, you know, the math, we did have some corrections. We just put out a new Explorer manual, which had some corrections for the math in it. So we'll see if we can get Dylan at the camera close enough. I don't know if we introduced Dylan. Did we
oh my
introduce
God,
Dylan?
no, Dylan is back with us. Dylan, who will only show his hand. Oh my God, he shows his face this time. Is that a special day all around?
So essentially, I have this set up just in an Excel. You could do it in other ways. And normally you would input the data you get here. I'm just going to, for convenience sake, cut and paste it in. And so what you get is you cut and paste this in. So essentially, as we look at this, the airplane took off at 184. So the first part is going to be the aircraft movement on the climb position. So movement 1, north-south, it went, the calculations here, 3,989.259. It's a negative, so that means it went south. We also get east-west is negative 278.956, so that is west. And then also, we don't need to report this, but we need it for later. The total height it got was 430 meters up. And essentially, this is all just from the data we get here. And also for this, we can also calculate this plane. It went 3,999 meters at 184 degrees. And from that, using degrees to radians, this is where we get these numbers of how far it went north and south. Okay? And then the next part is the plane's movement during descent without wind. So we're just essentially figuring out its flight path without the wind. We're going to do the wind next. And so the reason we needed the height is so we can figure out the time of descent. So we have, let me scroll up a bit, we have how fast it goes down, and we have a height, so we can determine that for this example, it took 71.667 seconds to get from its maximum height down, crashing into the lake. And again, we can use the data. We can figure out over here, it went 4,586.688 meters, again at that 184 degrees, and then using our degrees to radians, you can see how far it went south, 445, 75, and some west as well. And then for the wind we got here, so our wind, the equation you got for wind was negative 1 over 720 t squared plus 25. And so the position, the integral of velocity as you get, you can see the equation there. It's 1 over 720 times 3 time q plus 25 times time. And as we plug that in, we get the wind. Now, one thing to notice is, sorry, let's look back at this real quick, Dylan. It says here the wind direction is from 270. So a wind from 270 means it blows you to 90 degrees. So essentially, if the wind's from that direction, it blows you in that direction. And then we plug that equation in. And again, if you look on the mate forums and the competition help forum, we have all this spelled out because I know we had some issues with this. A lot of teams had some issues with this. But anyway, from the wind, of course, if the wind's blowing you at 90, you get no movement north and south because of the wind. And then we have, you can see it here, but the sign of wind direction times degrees to radians plus the equation times time of descent. And essentially we get 1,621.256 meters, and that's blowing positive, so that is blowing you to the east. And then we add all these vectors up, and we get, essentially the plane moved entirely negative, or south, so that means 8564.752 meters south, 1022.35 meters east, but we want that reported in distance and degrees, so when you do the math on this, you get essentially 8,625.554 meters at 173.193 degrees. So that's the total movement of the plane, and that's what you need to report to the judge.
And again, Matt graduated from Long Beach City College preschool. He can do that math today.
And I'll say, sorry. Yeah. Sorry about some of the math problems. I was telling these guys, it's been since I believe spring semester in 1991 since I did high-level calculus like this. Yeah. So again, to follow more of that math, I did post it online so you can kind of follow through the calculations for this example, and we did get an updated manual with the right answer in there. Okay, so hopefully if you have questions on the math, you can ask them on the forum board. I don't know, we're not going to go through the heavy math right here. Okay, so the next part is identifying the aircraft using the tail structure, and this is where you're going to use your image recognition. And so there's going to be one of 6 tails. So you have pictures of all the tails. There's a triangle, 3 triangles with red, yellow, and blue, and then 3 trapezoids with red, yellow, and blue. And your company can drive their ROV around wherever you need. So essentially this would be the tail. So actually Dylan would be our ROV. Since he has our camera, you could drive around here to see the side that has the writing on it. Or, I'll move around so Dylan has to move around. You could move around so you see the side with the red or colored stripe and the shape on it. So that's up to you, and you can position your ROV wherever you want. So if you need to get closer to it, if your image recognition can do it from further away, that's great. So you can move your ROV around to get whatever angle and distance you want from this tail. Okay? Now, I want to talk a little bit about, for your image recognition, before we go through, before you do your competition, we're going to have a testing of this, and that's going to be done to remember. What we're probably going to do is you can arrange to do this. Hopefully, what we're going to do is when you get to the international competition, you check in. We're going to hopefully have you then go to your safety check, and then if you're ready, you can come over and do this. So how it's going to set up is you're going to set your ROV up, and you're going to turn on whatever cameras, programs you need to do image recognition. And then you or a judge, you're going to go hands-free. So that means everyone steps away from the controller. And then you...
Oh, geez. Wait a minute.
That one?
Yeah, try it.
There we go.
Oh, there we go.
Okay,
Sorry,
okay.
we were filming me and Dylan.
Filming Dylan's chest, yeah. So anyway, you get your system set up the way you want. Go hands-free, and then, for angles, you or the judge, you can move this however close you want, whatever angle you want, whatever side you want to see. But what that test is we just want to see that it's your computer program, your image recognition software doing this. So we're not going to trick you by, having it at this angle. You can move it to whatever angle, whatever distance. So, if you want to get it really close, if you want to focus in really close on that, whatever you need to set it up. And hopefully, as planned, your image recognition software, for this one, you would put a red square or red rectangle on the a video overlay, and that would successfully identify this tail.
All right, we have a question. Unless
Okay.
you're a Patriots fan, we're really going to mess with you. Just teasing. There is a question, honest question about this. So during the setup for the image recognition test, the
Yes.
in-air test that you're just talking about, are the members allowed to fine-tune the software parameters to allow to adapt to room lighting, temperature, and exposure before being tested?
Yeah, we can. You could. Yeah, I mean, whatever light, because the light in the room is going to probably be different than what you're experiencing underwater. Yeah, you can get your system set up however you want. We could probably even test. Maybe we'll probably use just a different one, but test with that. Yeah, we're not trying to trick you or anything like that. We just want to make sure that it's your image recognition, because of course our brains are really good at image recognition. I can go, hey, red square, I know what it is, but we want you to design a computer program that does that. So yeah, you'll be able to set up as you want, get everything ready, then go hands-free, then we'll move this wherever you want in front of your camera, and hopefully your program will tell us the right tail, one of those six tails.
Yeah, and
Okay.
shout out to Lisa Bradshaw. Lisa
Yes.
Bradshaw, shout out to you for helping us develop, for suggesting this task and helping us to develop it. Thank you
Yeah.
so much, Lisa Bradshaw. Woohoo!
Yep, one of your
GM.
Explorer Class judges. Okay.
Former competitor.
Yes. Okay, so the next part of this task is, once you've done this, and of course I just want to say, if you can't do this, you can go on. You can skip the image recognition task, you can go on, but you can't come back later at a certain time, because this one has to be done in order. Removing debris from the aircraft, which involves 4 things: attaching the lift bag to the debris, inflating the lift bag to raise the debris, moving the debris from the wreck area, and then releasing the lift bag from the debris. So, Explorer teams, you are designing your own lift bag. I know we had a question from a Ranger team, but can you buy a lift bag? Yes, you can go out and buy a lift bag. But anytime you're buying a component like that, just be prepared to explain why you bought it versus why you didn't build it yourself. Okay, so here I actually do have a professional lift bag here. And so you would carry this down, and the first part is you're going to hook this to the debris. So I have a little hook on the bottom of here, which I would guide down and get that. And once this is here, I have a manual pump. You, of course, could have another one. I just have, Scott, will you pump that for me? And that's going to pump air up here, fill the lift bag. So it's not actually going to fill, so it's just coming out. And it's wet from sitting in my car, in the back of my pickup. But anyway, so once you get enough air into here, this will, you lift up. Now, the one thing is you can use motors to help pull this up, but you do, the manual says you do have to, part of this is pumping air into the lift bag. So then move it over to the side, put it down. Now, this is also important. The manual says you have to set this down on the bottom. So you can't have this part way up, do your release, and have this drop down. The third part of that, which is setting this on the ground, is setting this all the way on the ground, okay? And then you have to detach this lift bag. So for me, I'm going to demonstrate a manual release. So this one has a pin. I pull that pin, and the lift bag goes away. Now, this is one where we've challenged you to do some really interesting release mechanisms. So, of course, if you have a pull, you get only some points. If you have one where you're using a magnetic switch, so if you brought this down, had a magnet, and you have a magnetic reed switch in there, so when you bring a magnet close, it either opens and closes a circuit, which opens and closes something, which releases that lift bag, you get some more points. If you are using Bluetooth, Wi-Fi, or some other broadcast, EM broadcast for that, that's worth even more points. And then full points is the acoustic release. So if you're sending sound, now one thing about that is there needs to be your ROV that is transmitting all these. So if you're doing an acoustic release, you can't just drop a speaker into the pool by your station and broadcast something. It has to be, excuse me, coming from your ROV. Now another note about this is pools are very noisy places. You never know what's happening there. So even if you're using Bluetooth or Wi-Fi, or if you're using acoustics, we kind of said, what do we call it? Frequency selective acoustic release. Pools are noisy places. If you have your release that says, oh, anytime I hear a noise at 2100 hertz, it releases, that noise might be in the pool normally, because pools are very noisy places with an ROV in them. If there's 4 ROVs in them, it's even noisier. If there's 8 ROVs in that pool, it's even noisier. So by frequency selective, that just means, it might be a series of tones. So here's this tone, then this tone, then this tone for a set amount of time. So you might want to think about that for both, if you have a Wi-Fi release, maybe not just anything, it's a set signal.
We have a few questions.
Okay.
Are you ready?
Yes, I am ready.
It could be the Eagles fight song. Bonus points for that one. All right, so the first question, can the mechanical release be as simple as releasing a hook from a U-bolt?
So you mean mechanical release of just your ROV? Yeah, so if you had this,
just like you did.
Do this, and yeah, then your ROV goes down and does that. Yeah, that's a manual release.
Okay, yep. Next question from Samir, another question from Samir. Can we seal the Wi-Fi module using marine epoxy?
Yeah, for the one you built, and yeah, so remember, the nice thing is you're building both sides of this, so you're building the release and whatever's on your ROV to release it. Yeah, you can use marine epoxy for sealing that.
Cool. All right, last question so far related to this from Abdul. He says, for the release mechanism, are we allowed to leave something hanging on the U-bolt after releasing? Yeah,
so if there's a chunk of whatever on here, that's fine. That doesn't constitute debris or anything like that.
Sorry, another question came in. Each team, hopefully I pronounced that correctly, each team has to bring the lift bag, or are you guys going to provide that?
No, we are not providing lift bags. So you are building the lift bag, you're building the release mechanism. So whatever mechanism you have to release it down there, you're building that. You're building lift bag. On your ROV, you're going to have whatever sets off that trigger. So let's say, for instance, you're doing an acoustic, frequency selective acoustic release. You are building something on your ROV that's going to be making sound, and you're also building something on your release that's taking in that sound and thinking, hey, this is the right sound to release that. So you're doing both sides of that. We are supplying you with this and this. So we'll supply the big weight, the debris, but the lift bag, the airline tubing, the release mechanism is on you to build. Okay.
We have several more questions, including one from Scott, our audience. In the audience, here's a question.
We're pumping with the air pump.
Right.
Now, as far as delivering the air, it needs to come from the ROV.
Yes, the airline tubing. This one didn't. Well, I guess I'm the ROV. The airline tubing for delivering air needs to go through down to your ROV through the tether. Yep.
All right, the next question, there's a question about the OBS, the code for the OBS, which we'll get to.
Yeah, we're getting there.
We'll tell you where you can find it. Another question, since the airline pipe is supposed to be attached to the tether cable from the shore, and there are 2 lift bags that are to be inflated, can the pipeline that comes to the ROV through the tether be split into 2 pipelines at the ROV, and can the pipeline remain attached to the lift bag, or is it really necessary for disconnecting the pipeline from the lift bag?
So, it could be left on there, but I'm going to talk about for lifting the engine, you do need to disconnect there. So, yes, you can split it off. If you have 2 lift bags, you can have one here and one there. Okay?
Okay, we've got more. Oh my God, they're rolling it in. Another question, can we proceed to attaching a lift bag to the engine before releasing the one attached to the debris?
No, this mission has to be done in order. So you have to get this debris set on the ground and released, then you have to come back and do the engine.
All right, another question.
In order.
They're rolling in, Matt. Can the frequency selective acoustic module use a mechanical enclosure, sound damping, as a way to allow certain frequencies to pass and others not, instead of using electrical filtering methods?
I'm going to say yes.
Yeah.
Easy enough. Long question, easy enough answer.
Yeah. Like I say, you can set it up however you want, as long as it's safe. I mean, we have safety, and what did they say was in that?
It's a mechanical enclosure sound.
Okay. Yeah. If you're using anything like mineral oil or things like that, then you need to get it approved.
Okay, they're rolling in.
Okay.
Does the release mechanism have to stay latched onto the U-bolt, or is it fine if it falls off?
If you mean if it falls off, well, essentially, once you've set this down and released it, whatever happens afterwards, we don't care about.
Okay.
Within reason. I mean, can't damage anything, but yeah.
All right, next question. For teams who are videoing their attempt for international consideration, do the wind propellers need to be actual propellers, or can we use popsicle sticks, since they don't have to be spinning?
We'll get to that later, but yeah, you can use whatever you want.
Sorry, I didn't want to. Okay, let me see.
That's test 3. Yeah, use whatever you want for the video. We don't care if it's real propellers.
Another question about, they're coming in. After the releasing of the lift bag, are we allowed to pull it back in ourselves, or does the ROV have to bring the released lift bag to the pool side?
So for the one that's here that you released, you can pull that back by a cord or by hand. This one, which you're not releasing, has to be your ROV pushing back.
Okay.
Yep.
Next one. In the competition, the lift bag is going to be hooked to the U-bolt before the test, or do we have to hook it underwater? You have to hook it underwater.
So this is what you're going to find underwater, something like that. The hook is on whatever you built. So you're going to, where's my hook? Here it is. So essentially, you are going to have to come down on whatever hook you have. It doesn't have to be this. You're going to have to hook it onto here, and the same for the other U-bolt on the engine as well, which we'll get to in a minute.
All right, one more question. Is it okay to vent air through a venting tube up to the surface regarding the lift bag? Yeah,
so if you wanted to fill this lift bag with air, or partially fill it with air, move this, and then you have a release that releases air out of here up to the surface, or even out of this hole, to then help drop this weight back down. So you empty this air. Yeah, that's fine. Yep.
Awesome questions, everybody.
Okay. Are we no more?
We're good for right now.
So the next part, this has been deployed, and just one other note about this. This doesn't have to be far away, but you don't want it right now, but a little bit away from that. Okay. So the next part is on the engine. There's another U-bolt, and you're going to have a lift bag to lift this engine up. And for this one, again, hooking to the U-bolt. And for this one, a little bit different. For the debris, your ROV can help, of course, move, lift, and pull this down. You do have to inflate it. For bringing the engine up, it needs to be the full lift bag. So when the engine goes up to the surface, your ROV is not dragged up with it, or you are penalized. So let me get this set up again real quick. And if this is a different one, you don't need a release on here. So if the engine is just bring up and bring back the surface, so you don't need a release. I'm just setting this up so it's proper. So get hooked on here, fill this with air, and when you get enough air in here, it's going to go up to the surface, and then your ROV needs to push this back to the side. Now again, when this gets enough air into it to bring this to the surface, we want your ROV to stand by. Now, if your ROV's here and it comes up and it gets bumped a little bit, that's okay. But if your ROV gets dragged to the surface with this, you are going to get penalized 5 points for that. Because we want this lift bag to be independent, so that when it goes to the surface, you stay down on the bottom. Just like a real airbag lifting thing would kind of work. Okay? Okay, I think that's it for the aircraft task, unless there are additional questions on that.
No, not yet.
So now we're going to move to the OBS section. And so the first thing, we're going to have Scott come up to be my Vano light.
Thanks a lot, man.
So the first thing you're going to have to do is you are developing an inductive coupling connector to power this. So we've given you, the specs for this, the part numbers and where to get this. And then you are going to bring this down, and you get points for getting it so that, it doesn't have, we have it set, I don't want to say pretty loosely, but, you can see right as you start getting in there, the light goes on. So, yeah, it doesn't go on if it's outside, but once you start getting in there, and that'd be good enough. So you get points for getting the puck, I think we're calling that the puck, into the port, and then getting that LED to go on. Now, the other thing this is doing is, once this LED goes on, you are powering up, or at least, saying that's powering up, you're doing it. So once you have this in, we're going to start, connect with Wi-Fi. Sorry, where are we here? And so connections can be made to a Wi-Fi point. Yep. And so what you're going to do is you're going to connect to the Wi-Fi, and then you are going to link to a web page. And the web page access is 192.168.4.1. So you're going to get your Wi-Fi to connect up with that, and then you're going to go to this web page. Now,
and yes, we are going to publish the
yes.
software.
Yep. Don't worry about writing that down.
Yes.
Yeah. Well, that's already out there. This that web page access point I put out online. If you go to the forum boards, I pinned 2 things to the very top. Timmy, our registrar, has pinned something else, but I pinned the aircraft flight data because I know there were some issues with that, and I've pinned some of this information. I'll put more information in there.
We'll get
so
stuff
all there. Yeah.
We're going to get stuff in the Dropbox too.
Yeah, and then we're going to publish all the programs for this are going to go in a Dropbox. Actually, the folder's already there. So if you ask Jill, hey, can we get those SolidWorks files? It's in there. Now, there's nothing in that folder yet, but it will be very soon.
I have questions. Are you ready for them, or you want to get through this?
Let's wait just a touch more. Okay, so as I said, the web page, once you get the puck in, it's going to start displaying things. It's going to display voltage, and it's going to start displaying your X and Y angles. So you can kind of see what you're going to see once it's powered up. Okay? And then you're going to balance it. Now, we're not turning the handles to balance it, but it was unbalanced, and once it gets balanced enough, once it's within parameters, and I'm going to talk about those parameters in a minute, you're going to get an update, and it is going to give you those 16 data points there. So that's going to be added to the web page when this is leveled.
You'll get the update by hitting the refresh button on the page, and it refreshes.
Yep. So yeah, you refresh, and then you get that data. And so, and again, X, Y. So yeah, if you come over here, Dylan, with the camera. So this is, I don't know how close you can see, but on our little level there, you can actually see the X and Y axis, but this is your Y axis along this way, and then this is your X axis. So you can kind of use how this is set on the OBS to determine which is your X and which is your Y axis.
On the axis with the LED, the puck, and the level, that's the Y, the opposite axis.
And of course, you're going to be turning these to level it, not do that. Now, one other thing is when you do get the data this level, you want your ROV at least somewhat off. So, you can't be doing this with your ROV. You can't be lifting a corner of this with your ROV to level. You're leveling it by turning the handles on either side as needed.
They're a little loose.
Oh, yeah. Okay, I got to tell you. I was like, that one's not working, but okay. And then, so we'll get through this, and then I assume there's about 50,000 questions to answer.
There's several.
Okay, so you're getting this data, and then you're going to put that data and make a graph out of it. So number one, once you see that data on there, you're getting points for that. And then you're going to plot this data, and what you're going to do is you're going to plot each of these 16 data points just against time in seconds 1 through 16. So essentially that first data point is going to be 1, second data point is going to be 2 seconds, and I'm just going to cut, oops, oh man. Now normally you wouldn't cut and paste because you would have to get these data in. I'm going to do it a little more easily. And paste that in there. And then you're going to get a graph that looks like this. So you get points if you put this in and you get a graph. So you're going to see the data point should look something like a seismograph. You're going to get ups and downs. And then the judge is going to do a comparison. Is your graph similar to what it should be? And you'll get more points for that. Okay? So that's it for that. But I assume there are some questions. So let's get the first one.
So for the OBS, how are we going to test our seismometer, and how do we make sure our seismograph is accurate or not?
So,
If you have the data and it's plotted.
yeah, if you have the data, so essentially, to know if it's accurate, like I say, it's just the 16 data points you get against a time of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I used Excel here to make a quick plot, but essentially, you're going to get a couple up and downs every, so there, and just a little hint for those watching, it's going to be 0, then an up, then a down, or it might be down and up. I might confuse by going down, up. Then another 0, then another 0, a down or up or down. And so you're going to get these up and downs that looks like a seismograph. I don't know, playing with it, you can make up some data points. Now at the competition, we are going to have a practice area too where you can go down and practice. Because we know that this is probably the more complicated of the missions. So at the International, we will have a practice zone. It's probably going to be in the shallower water, or you can go down and practice.
All right, you ready for the next
Yes.
one? Does the inductive coupling need to stay attached to the OBS after lighting the LED for the Wi-Fi readings to be transmitted?
Yes. Yep. Yeah. So that puck has to be in there for the entire time of task 2. Now, if you've done all of task 2 and it falls out or it's taken out, that's okay.
But as soon as you knock this out,
this goes.
The LED goes off and the web page goes dead.
Yeah, it goes back to just saying the top line mate.
Well, actually,
no, it goes back to nothing.
It goes back to this right here. You'll still stay connected, but you'll see this.
Yeah. Yep. And it'll probably say 0 volts.
That's exactly what it says.
Yep. Okay. Next question.
Yes.
Is the Wi-Fi being broadcast from the OBS underwater, or is it on the surface?
No, it is being broadcast from
right here. I'll turn the light off. There is this little device right there. You can see the antenna. That is the Wi-Fi device, and when it's underwater, it will be sealed in epoxy, and we'll keep that epoxy to the minimum needed to provide sealing.
Yeah. And so that's just one other thing. None of this is waterproofed yet, but it will all be waterproofed in epoxy. It's for transporting and doing all that. It's easier.
Yeah.
Well, it will be potted. Let's put it that way.
Okay. Do we have to bring our own prop for the OBS?
Nope. So this is provided for you. You need to bring your power, inductive coupling, and you need need to get Wi-Fi data.
Your Wi-Fi transceiver.
Yeah, your receiver.
Ready for the next one?
Yes.
If the Wi-Fi connection gets interrupted in the middle of the mission, and we had to rely on the bubble leveler for a while, but eventually the connection was established again and we showed the correct leveling results via Wi-Fi, although we weren't receiving the Wi-Fi data throughout the entire mission, can we still claim the Wi-Fi points or just the bubble leveler points?
That's a good question, and that's one we're probably going to debate. So my recommendation is post that on the FAQ board, and we'll think about it and answer that.
So
and that's something we're going to have to get together with a lot of the judges and discuss this.
That's a great question, Samir. Great question. So post it. We'll have a discussion. We'll get back to you. Okay, next question.
My initial thoughts are
Latest reply from Mate states that the Wi-Fi data will be updated on the web page as data 34 123 456 negative 123 negative 456 34 56 33,300 101 990 100 minus 34 55.
That's the data that you
do the numbers. Let me finish the question. Okay. Do the numbers represent individual coordinates with equal time interval in between 2 subsequent data points, or do we take every pair of coordinate as a line for data plot?
Those are the y-axis values, and time is on x, and time is every second. So the x-axis is not included here. This is just the y-axis coordinates of those points.
And so you're going to get the 16 y coordinates. So the x coordinates will be 1, 2, 3, 4, 5, 6. And I think that sounds like the numbers you sent me.
That was the numbers I sent you a long time ago. Yeah, those were just random numbers.
Yeah, they're random numbers. I am going to, I don't say make the numbers, but I'm going to make it so it looks somewhat like a seismograph like that.
And in that group of numbers, those were all integer numbers, but they can be integers or floating point with decimals in
Yeah, it'll probably be like a 6.1. I'm not going to go to 6.25. It'll be 1 decimal point.
Okay, if we place the puck into the port and the OBS is then powered, will we still get X and Y angle data if the puck is then removed? We talked about
No. Once the puck's removed, any data shuts down. It goes back to just saying you have 0 volts.
And that's just like a regular, if this was powered, the intention is this has to be in place to power this device. If you take that puck out, it's not powered, it's not transmitting data anymore.
Yeah, and so just kind of a background on this is, look there, Mbari, one of our local institutions, they're kind of looking at, ways to power and transmit data more easily than making plug connections and things like that. So we're kind of...
And they're looking at possible student projects and making this inexpensive instead of having a real expensive connector for data and power, have ways of doing this. And so a lot of this is proof of concept for that future thing that a lot of you will be hearing about. It may actually have the ability to go and build a scientific project and put it down at the bottom of Monterey Canyon.
That would be fun. Okay, so I have a question that I can answer. So just for clarification, Mbari is the Monterey Bay Aquarium Research Institute, and it's located in Moss Landing, which is just a bit up the road from us. So there was a question from someone about the ASEAN Regional, and why does it only show Ranger and Scout? It only shows Ranger and Scout because if you are an Explorer class team, you need to register through the International Qualification Portal. So if hopefully that makes sense, if you go to the registration, it'll say all Explorer class teams register here. Click on that and follow that. Don't go through the ASEAN Regional website or through that registration portal. You won't get there. So if you have questions, just email me afterwards. Hopefully you have my email. You should. We'll get you taken care of. Back to the next. Oh, lots more questions came in.
We're never getting out of here.
What do the X and Y coordinates represent in the seismograph? Time versus displacement or something else?
It's time versus amplitude.
Amplitude,
yeah, amplitude of an earthquake. I made data points that are going to look something like a seismograph, and technically a seismograph is going to be going up and down a lot every second. We wanted 16 data points, not 200 data points. And
take a picture of that.
Yeah, so if you look at that, this is also published, although the graphs are slightly different. There may not be in the manual. There may not be 16 data points, but we're going to be doing 16 data points. Plotted that way.
All right, next question. Will there be a change in data received if Wi-Fi connection is reestablished? Will all 16 points be updated at the same time?
Yeah, so essentially, once it's level and once it is powered and leveled, you're getting 16. That's never going to change. Now, a different station is going to have different numbers, but that's never going to change. What this webpage is showing, you're going to get 16. Now, if you lose Wi-Fi connection for a bit and it goes away, you come back, it'll be those same 16 numbers.
Yep.
Okay, next question. If I just skip the step in which we put the debris on the ground and directly release the debris, I will only lose 5 points for what?
Sorry, say that again? For debris.
So if they skip the step where they put the debris on the ground, so it's not on the ground, say for example it's still holding, wait a minute, and directly, it's not on the ground, but they directly release it?
So if you release this, if you release this and it falls, you're not going to get points for that, and this has to be done in order, so you're not going to get any further points beyond that. So this needs to be set down on the ground. As per the manual, it says this has to be set down. And yeah, we don't want it released from up here, because then it will fall down. And just one other thing, sorry, I should be looking at the camera, not the computer, is we're probably going to have some sort of zip ties to hold this in so that if it does fall, the bricks aren't going to come fall out. Maybe some rope over there, we're going to secure that a little better, but it won't interfere with the
And we'll have to work to define how high is high, right? So we're all consistent in terms of judging. Like if you release it an inch off the ground, is that acceptable versus a foot? So we'll make sure that at the competition, the judges are correct accordingly.
And what's it going to be is this, at least one corner of this, because the corner is always going to be first, should be on the ground. So if you had it like this and released it, that's okay. But if it was even up there and released it, that wouldn't be. It needs to be on the ground when it's released.
So there was some questions about, so again, the code for the Wi-Fi data transmission It's coming, it'll be posted in those Dropbox folders. So if you've asked me for access to the SolidWorks, those folders will now contain a folder that's all about this OBS mission and will have the information you need. So the other question, which I think is related, is if the soon-to-be released code is updated, will we be notified?
Yep. Yeah, if we make any updates to the code, we'll not only update the code in the Dropbox, but we'll send out
Notice.
Yeah, notice, because essentially we can, through active consent, a notice to any team registered about on any updates. As those of you who are registered, you might have got some yesterday that said, hey, we've updated some manuals.
Right. Okay, so far, this is the last question right now. Does my team have to get the Wi-Fi data from the web page at the control station only, or can they extract the data onboard the ROV and send the data throughout communication protocol?
I didn't understand.
They can capture that data however they want. If they want to, if they want to go and do a, you don't have to do a web page transfer. If the ROV can connect to the access point, do a web transfer, extract the data, pull it out and everything, no problem. How you get the data, it's going to be served up as a web page. If you want to put a web access down on your ROV, go for it.
Okay, another question came in. Will the leveling mechanism be significantly complicated to adjust? How many PVC pipes before available do we have to rotate on average? Well, that's like a big hint.
Well, that's kind of up for you to figure out. It's going to be, they'll essentially, they'll all be set the same throughout the station within tolerances, of course. But how many you have to turn is up to you. Yeah.
It's variable.
Yeah.
Yeah. I mean, they know what this is. They know how many, what the pitch is, and
so there's the parts. I think for all those out there, I answered it on the.
We're not going to switch from SAE to metric.
Okay, I think for now we are done.
Okay, well, with task 2.
Yes. We are done with questions for now, and on to the next task.
Okay, for task 3, energy. There's a lot of equipment to install. But before you install the equipment, you get to, you're going to go on the Deep Zoom website. So actually I have that called up. And where did my mouse go? And so if you look at, okay, so kind of the north end of Puget Sound, Admiralty Inlet, you get this area where there's 6. Was it not showing? Well, we'll zoom out a little bit. Okay, so you have these 6 tidal points, and then as you go through the day, and play this day, you're going to see it follows the tide. So the arrows get bigger, and this is just what the current's doing in each of those 6 spots. And what you need to do is you need to analyze which one of these is the biggest for that day. So which one of these has the most. Now you could do it by, you could take, when each of these is at maximum, you could take each of those maximum values and add them together and go, oh, of the 4 maximums, because you're going to get essentially a big incoming, a big incoming, a big outgoing, a small incoming, and a small outgoing here. So you could add the maximums of that, or you could just look and go, I'm looking at today. Yeah, so it's running through March 15th, which is today. And as I look at this, to me it looks like that top middle one. Yep, top middle one's the biggest there, 4.2. It's higher than everyone. All the other 6. The outgoing looks like for the outgoing that those 2 are the same. Maximum. This one was the biggest and that one. So you can just look and evaluate which of these is the biggest outflow. And on this day, I'm looking that top middle one is the one. Now, there's one other thing to consider here. Is which of these are in cable area. So it's really hard to see, but between here and here is a cable area. So this one, the lower right one, is in a cable area. So that one wouldn't ever be used because it's in a cable area, and so that one doesn't count. This one's right on the edge, so we're going to say, hey, it's on the edge, it counts. So that one would be a potential one, and the other 4 aren't close. So essentially you're looking at these 5, and again, on today, March 15th, this one's the biggest, okay? So you're going to make that evaluation and tell the judge, hey, we think that one's our biggest. Okay?
We've got some questions back on task 2.
Okay.
If you are ready for them. so we don't lose sight of
Yep,
it.
yep. We'll go back to test 2.
How is the Arduino board of the OBS placed? Is it just taped to the side PVC?
It's going to be set up more or less like it is on here. Everything will be waterproof.
It'll be like that, but enclosed in epoxy. We're just going to epoxy the Arduinos.
And and one other thing I know I got asked on the FAQ board, and I didn't answer at the time because I didn't know yet, is we're going to have some weight in here, and we're probably going to attach a guide weight or 2 to the underside of this. So there's going to be probably 5 to 8 pounds of weight on this. I'll play with that some, and I'll let everyone know how much weight we put on them. But just some weight to hold it down so that when you're turning this, you got some weight so it's not just bumped around.
All right, next question about, well, back on task 2. Could we use a non-ROV device to level the OBS? Like have a device that gets dropped on, hold on, let me finish. Like have a device that gets dropped on and levels the OBS without the ROV.
No, so it's not allowed. So for non-ROV devices, for Explorer, you are allowed 2 non-ROV devices. One is a power puck, and one is your release mechanism. So you can't go, oh, I want to do this as a non-ROV device. Non-ROV device is well, 2 things: your power, inductive coupling power, and your release. So no, you can't have any non-ROV devices other than those 2 things.
Okay, another question: in what mode will the Wi-Fi be access point or station, and how will be the pairing with the Wi-Fi? Sorry, I'm just...
Scott, did you get that one? I'm
sorry, what was that?
It says in what mode the Wi-Fi will be access point or station, and how will be the pairing with the Wi-Fi?
It's an access point, and you'll be pairing with it by using the SSID Mate 2018 as published. And there's no password. Make it really easy. You select it, connect to it, and go to that web page, and away you go.
There you go.
Yep.
Thank you. All right.
Okay, we're good for now?
For now.
Okay, so the next part of task 3, after you evaluate that tide, is then you're going to use some data to calculate the maximum possible megawatt generation. And so if you went to the manual, you can see the equation. We published it there. It's the power equals N, which is a number of propellers, number of number of what?
Blades.
Not blades, number of propellers. Times half times rho, which is the density of water, which we're going to always use 1.0254, and that will be given. The area, the velocity cubed, and then the efficiency of the turbine. So at your station, you are going to get something that looks like this, and it's going to have the diameter of the rotors, which in this instance we're going to say is 16 meters. Efficiency of the turbines is going to be 32%, and seawater, we're always going to use this as the density. So you're going to go through, and I actually did some of the math here. So the number of rotors is 4, and that's from the mission props. If you look at the mission props, the turbine array you're carrying down has 4 rotors on it. Going to use the density there. So the swept area, pi r squared. So we know the diameter is 16 meters. Radius is 8 meters. Square that times pi, and you get about approximately 201 square meters. So the velocity, so when we come back to here, as I look on this, the maximum velocity is 4.2 knots. So if I watch this, I would just miss it, so I'm going to actually go back. So right sometime in the morning right there, this one gets up to 4.2 knots. You can also look over on the right-hand side. Okay, that's not right. Well, anyway, this one got up to 4.2 knots in the morning. So right about, let me get it stopped there, 3.1, 4.2 knots. So that's the largest flow for the day. So 4.2 knots, of course, knots doesn't do us any good. We want that in meters per second. So did the conversion, 4.2 knots is 2.2 meters per second. We cubed that, so it's velocity cubed. So that's 10.648. The efficiency, 32%, 0.32, and we multiply those all together. So it's 4 rotors times half times the density, 1.025, times 201 swept area, times 10.648, which is flow cubed, times the efficiency, and you'll get a number. In this case, we're getting 1404 kilowatts. which of course when you convert to megawatts, it's 1.404 megawatts. 1.4 is good enough. You don't have to carry the decimals out that far. So 1.4 would be good enough. We'll probably take somewhere around 0.1 or 0.2 plus or minus. So, you know, anywhere from 1.3 to 1.5. Okay?
And Matt could do that math because he graduated from Long Beach City College. Hey, question.
Yeah.
Back on task 2, believe it or not. If the power puck was part of the auto leveling non-ROV device, would it count as a single non-ROV device?
No, so you can't have anything on a non-ROV device other than what it's intended to do. So you couldn't have a power puck that also levels things. Your non-ROV device is the power puck that provides power only, and for this it's the lift bag release mechanism. So essentially, you are going to have to turn those handles with your ROV.
Oh, wait, we have a question about task 3.
Oh,
What's the possible range of energy?
You mean the megawatt generation, I'm thinking?
I hope, yeah.
I don't know, anywhere from 0 up to, well, yeah, I don't know, it could go anywhere. So I'll tell you, just looking at, I've played with lots of currents, you know, the current sometimes gets up to 6.5 knots there. So that's probably your maximum. Your efficiency is going to usually be in the 30s. These turbines, that's about the efficiency they have. So I can't tell you that it's not going to be super high. You know, we're not going to have like 5 million megawatts, but it could go up to a couple megawatts, maybe even up into the 10, 12 megawatts. I don't know. Okay. Any other questions?
Not right now.
Okay. So where were we? Okay. So you've done your math. Turn that in, Judge. You know, sometimes you say, hey, Judge, this is what we got. Okay, and then now we're going to move over and do some of the props. So this is what's going to be on the bottom. I'm going to move this chair. So underwater, you're going to have your red square where you're deploying stuff, and then your pipe out, which has some length measurements on it, and then you're going to have your ion base. Now, for deploying all this equipment, you can do this pretty much in any order you want. Now, obviously, you know, you have to deploy the base before you can put the turbine in it. So, but we're just going to do it in order. So the first thing you're going to have is you are going to have the turbine base, which will be on the surface, and you're going to carry it down. Now, this doesn't have a lot of good attachment points. You know, we didn't put a U-bolt on it or anything, so you're going to have to figure out how to carry it. And then you are going to put it down completely in this square. So that wouldn't be good enough because it's hanging over. You need to get it completely in that square. So that would be good, but that wouldn't be good. That wouldn't be good as well. Okay? Now, also, depending on how you do this, you want this, actually for deploying it, this could be on either side, but for the next step, is going to be carrying down your tidal turbine array. Carry this down, drop it into there. Okay? And then you are going to latch this by turning this handle. There you go, latches over. So just one thing to note is that when you put it down, if it was like this on this side, and you drop this in, it's not going to latch. So just make sure when you put this in there, this is on the right side so you can latch it up. Okay?
We have some questions. Would you like them?
Sorry, I don't have this for you yet.
Okay.
Are they on task 3?
Yes. Yes, they are.
Okay.
Does the velocity, I think this is supposed to say, does the velocity depend, is it coming from the map?
Yeah, so you're going to get the velocity from deepzoom.com. So whatever spot you select, so in this case it was the top middle, you're going to look at the range, the numbers you get throughout that day, and you're going to use the top one for that day.
Good, and these are very appropriate questions. You just talked about these things. Can the company develop a part prior to the competition and use it to act as a grab point for the turbine?
Yeah, so if you wanted to, well, the turbine array has a nice U-bolt, but if you wanted to develop your own, however, for anything like that, that would constitute debris if it was left in the water at the end of the mission. So if you had something on this to help carry this down, that's fine, but you are going to need to remove that before the mission ends or you get a -5 points for debris.
Okay, another question. Sludbotics, I love it. For the turbine and turbine base, can we insert them in the claw of the ROV on the surface?
No.
Or are we required to drop them into the pool and have the ROV pick them up?
No, so you can put these on the surface. You can put them. Actually, for that, well, I would say the choice is yours for this. So you can attach this to your claw on the top and this on the top. This one, if you wanted to, you could drop into the pool and go retrieve it off the bottom. You can't throw it out, but if you want to drop this right at the side of the pool and retrieve it, you can do that. This has to be carried down by RV. So one other thing I want to say is you can't in there, then this has to be put in there, and then it has to be closed. So you can't like attach things on the surface and carry it all down as one, but you could. Say I'm an RV, I have this in one claw, this in the other claw, I could do this. Go down, put that there, put that in there with my other claw, close like that. So that's fine. You don't, and for all of these, you don't have to go up and down every time. If you can carry down 8 things at once, that's great. Although I think we only have 4 things to carry down.
Okay, a couple more questions. Sam, I can't read Arabic, so please translate that for me. And the next question is, if the base moves outside the red boundaries while latching, do we have to move it back?
Nope. Once you get points for getting it in there, you're good to go. We're not going to take points away if while you do this, that happens. Or something like that. Okay?
Okay, that's all for now.
Excellent. So the next part is, we've got it installed and latched. So installing the IAMP, the Intelligent Adaptable Monitoring Package. I've said this for all the other classes. If you go online, there's a really cool video about what these IAMPs do. They're just really cool things that can actually sense what's going around. And for turbines, if like a whale's coming by, some big mammals, seals, sea lions, or even up in the Pacific Northwest, if a group of salmon swim by, these sensors can detect that and shut down the array so the animals don't get injured. And some other cool things. So watch that video, it's just super cool. Okay, so transporting the IAMP down. So again, this will be on the surface. You can carry it any way you want, but we've got this nice U-bolt for you to carry it down. And you need to get it on here, and it needs to be, the legs of this need to be on the stand. So actually it needs to be balanced on there. So if you drop it from a height, that's not good. But it'll stay there. It'll actually stay there all the way to there. It will balance on there. But if you get it a little far off, so the elbows on the end need to hang over the edge. If you don't, if you get it there, it is going to fall off. But you get it on there, release it, and you're good to go. And the next step is, again, latching it. And for that, or locking it, sorry, not latching, that was the last one. You're just going to push this right over. And once you got it that far, so the elbows are over, that far, that would be enough to consider it latched. Okay?
Question.
Yes?
I'm not sure I understand this. Can the tether man readjust the turbine and turbine base after dropping them to the pool side?
Your tether man's not going to be able to.
Your pilot can pilot the ROV.
So yeah, if you decide to drop things down to pick them up at the bottom right by the pool, they're down there. Your pilot can go get them. I'm not sure exactly what that question was other than that.
Ask it again if it wasn't.
Yep. Maybe using the tether.
No. We're pretending, so anytime, using the tether, pulling on the tether, you're not allowed to adjust mission props with that. We are pretending, even though this isn't a clear pool, we're pretending this is deep ocean, so that generally the person on the side, the tether man, is not going to be able to see what was down there. That's what we're pretending, even though we do this in a clear pool.
All right.
This year. You never know what we'll do in the future.
Yeah, right. Next question. Will you put weights on the yellow base?
There'll be probably a brick or something to hold this down so that it's, I only brought the bricks I needed because lugging bricks is tough. Yeah.
Hey, so I think this question means, can you show how you latch the IAMP again?
Yep.
Illustrate that again. They just want to know.
So when you come, so if you get close, so this is a 3/4 inch pipe here, and so this is 1/2 inch, and it slides in there. So this will be set like this, and all you have to do is push this over, push this in, and this will slide in over. Now, one thing to note, my hands are really good manipulator. If you're pushing down on this, it doesn't slide. Of course, this, as I said, would be weighted. But if you're pushing 2 down or 2 up, it won't slide. But if you get it fairly level, it slides quite easily over there. So you're just pushing this in and out. Well, you're pushing it in. The diver will take it out between missions.
Yeah. All right, so we're going back to the OBS mission again. For the OBS, the components we use for testing have to be the same ones that are in the prop building manual. For example, I want to use a newer Wi-Fi module instead of the one in the manual.
For testing, you can do whatever you want.
But we're going to have
What's
there.
Yeah.
Right?
And so if you
probably
test
want
it-
to test with that.
Yeah. You can use whatever you want. I can't guarantee it's going to work with.
Yep. Yeah, for testing, you can do whatever you want. Okay. Anything else, or are we moving on?
Nope.
Okay. So the next thing is placing a mooring a given distance from the base and measuring that out. So you'll notice attached to this is this going to be a chunk of pipe with some marks on it. And I know had some people ask on the FAQ, how long could this be? It's not going to be more than 3.1 meters. So, maybe 10 feet, or maybe a little less, depending on cutting down, because that's what we get in the U.S. is 10 feet of pipe. But anyway, what you're going to have to do is the judge is going to give you a distance. So in this case, let's say the judge tells you 1.49 meters out. So you're going to have to measure this, and you can do it any way you want, but I'm going to do a simple tape measure pull. So I have this on the end of my tape measure, and just so you know, I know that this adds about 9 centimeters, and so this is your 0 mark. The middle of this is your 0 mark. So I'm going to hook this around here. I'm going to pull this out, and since I know this adds 9 centimeters, and I want to go to 1.49 meters or 149 centimeters, I know that when I reach 140 on here, I'm actually at 149 because of that distance there. So I'm going to pull out and go 120, 130, 140. So hey, right here is 140, so it matches up with this mark here. Okay, so I'm going to show the judge that, hey, right here is 140 centimeters out. Or sorry, 149 centimeters out. But I'm going to explain to the judge that even though my tape measure says it's 140 centimeters, that adds 9, so this total length is 149 centimeters. Okay?
Okay, we have a question.
Yes.
Well, first of all, Sludbotics wants to know if there will be a quick general Q&A after the prop demonstration. Yes, we can do that. We can stick around for that. The next question related to this is, are the colored markings placed at equal distances? And
No.
will they be different from one station to the other?
So no, they are not at equal distances, and yes, they could be different between one station and the other. And kind of, I think I might know where this is leading. I highly recommend never using any of our props to say, oh, this is, this distance out. Because everything, when we cut things, there are tiny tolerances. So if you're doing an estimation, if you go, oh, this is 40 centimeters across from here to here, as it says in the manual, or sorry, the prop building, there may be slight differences. So actually what we recommend is never use any of the props that I have as like a baseline for estimating distances, because small errors from cutting will add up.
I think this question comes from the fact that Scott just stepped on the area. Is the base going to be weighted down? If I use a tape measure, will it be heavy enough for it not to be pulled with the tape measure?
There will be some, this is actually, I don't know, let's see if there's usually some rebar, a chunk of rebar in here. So it's not going to be super, super heavy, but if you pulled on it really hard, yeah, you'll be able to move it. So you want to be a little gentle.
Oh, can we use an accelerometer to measure the distance?
You can use whatever you want to measure the distance.
Whoa.
As long as it's accurate.
Yeah.
Yes.
So again, if you're using an accelerometer, it's on you to have it accurate. And again, like I say, if you're using estimations of something prop sizes, that's on you. Okay. Any other questions?
Okay, not right now.
So we knew that the mark, the 149 centimeters, was the blue-red mark. So the next thing is, we are deploying, my weight came off. You're deploying a mooring. So this is going to go down this way. Came off, but hang on. It won't be hanging down like that, it'll be up. But you're going to deploy this. Now, I will say the length of the chain is determined by the depth of the pool. So the chain will, for Explorer, at least at the International, is going to be much longer. And essentially, from the very bottom of this to the very top of the flotation package should be the depth of your pool plus about 10 centimeters. So this should sit 5 to 6 centimeters up at the top of the water. So anyway, you're going to bring this down and you're going to set it near that mark. So I knew we were near the blue-red mark, so I'm going to set that down. Now that would be good. You could go to the top, you go on that side, anywhere in here would be good. And then this will, of course, float up, this on the surface, this down there. Okay?
Hey, we have about a question about measuring.
Yep.
Can I measure distance using image processing software through the camera or have to move the required distance then report it?
If you're using image processing to determine, to essentially estimate a length, that's fine. Again, don't count on any prop that I have down there to like be exact to tolerance. You know, there's tolerances in everything that gets hand built. So you know, if you're estimating, but if you're using image processing, determine length, that's great.
They might want to bring their own reference down there.
Yep.
Bring your own reference down there as opposed to using the props as a reference.
Yep. Yeah. So yeah, don't use a props or a reference is what I recommend. Yep.
And if the reference is left, that counts as debris.
It does. Yep.
Yes.
Yep.
Yeah, good one.
Okay. So once the mooring is there, the next thing you need to do is measure the height of the middle of this U-bolt. So this, as I said, will be sticking up like that. This will be floating on the surface. Of course, we're not in the water here, so it's not. But you are going to measure the height from the bottom of the pool up to here. You can do that however you want. Tape measure, you could make a hook. And actually, I know that from the base of here to here is 18 centimeters, I think. This adds a couple more. So, you know, I could do you could pull a tape measure, you can do it however you want, but you need to get an accurate measurement of that. So right now, this is 117 plus the 18, so 140 centimeters up. Okay? Maybe a little more than that, but that's what you're reporting. You get the height right to the middle, and you're measuring right to the middle point of this U-bolt. Okay? And then, once you measure that height, you are going to design your own ADV, acoustic Doppler velocimeter, and you're going to attach it on. Now, how you attach it on, again, this will be floating here. You're going to attach it to this U-bolt. How you do that's up to you. I'm going to use a highly sophisticated method of using my two excellent manipulators to tie a knot in a rope. Now, I don't recommend this method. Of course, if you do develop grippers that are so good you can tie a knot in rope, remember, it was my idea, so share your profits with me. So anyway, so I'm going to tie this on now. A couple rules about this ADV. It needs to be at least 20 centimeters long, so this is actually 21 centimeters, just to be safe. And then I'm going to use my manipulators to tie a knot to tie this on. Again, don't recommend this method, but you could do it. There you go, so it's tied on there. And this would be like it. Okay, so that's it. You attach your ADV.
And Matt, so I know you went over this, but another question, is there a certain distance between each piece of tape?
There is not a certain distance between each tape. It is random. Yep.
Got a question for you.
Yeah.
Can you deploy that assembly?
No. This you need to have this set down. So the question was, if you didn't hear it, can you tie this on the surface and then bring this down?
No. Can you deploy the thing in your hand?
The ADV.
No, the hook in your hand.
Yep.
Can you use that to deploy the assembly instead of down there? At the bottom?
Yeah. So you're asking, can you use this as a grab point to drag this around?
Right.
Yes. Yep. Yeah. You can, whatever you want. I've attached a couple of U-bolts to be convenient, but if you want to grab this chain, that's fine. If you want to carry it around by the top, that's fine. If you want to carry it around by the bottom, that's fine. So yeah, whatever carrying method you want.
Can we use a pressure sensor to measure the distance?
Yeah, whatever height, depth measurement you want. If you're using a pressure sensor, just remember that generally gets you from here, from the top down, and we're actually looking for this down to the bottom. And just be careful, don't go like, oh, it's 17 feet minus that, because it may be 17.4 feet. So, yeah. Okay. Getting near the end, I think. So, actually, we're getting right at the end. So, that's it for the mission props. That was the last mission. So, just some general stuff. I said I was going to talk about the order that you have to do the tasks. So, portions of each task have to be done in order. So, the airplane task Has to be in order. This one, pretty much, you have to do it in order. You're not going to get to the next step. But this one, task 3, you can kind of do whatever you want. You have to do the Deep Zoom website first, but then you can go on from that. But you could start with anything you want. So you could actually start doing this, then move on to task 1 and finish up with this. Do it however you want. But here's a hint for everyone. There are 2 tasks. The first thing where the first step you're doing doesn't require the ROV. So the airplane task, your first step is doing the math, which you have to do. That requires nothing from the ROV. Task 3, the first thing you have to do is look at the Deep Zoom website and do some math. That requires nothing from the ROV. So just think about that. You might want to have someone, the pilot may be going down and doing something on task 2 while some people do the math for task 1 and 3, and once you get that done, then you can go do what you want. Just something to think about. So again, just some general notes. We're almost done here, so post questions if you have them. If not, post your questions to the board. I will get them answered in a moderately reasonable time. Dropping items into the pool to retrieve them. So a lot of the items you can drop down, but again, you can't throw them out. So for this, you can't toss it out and hope it lands in this square. But you could drop it down the pool. Now this, as I was saying earlier, this is the one exception. The manual states you have to carry this down with the ROV.
What about use of an elevator?
You could use an elevator or something like that, a basket to carry things up and down, again at the side of the pool for dropping these down. This, you couldn't. This has to go down with your ROV. So some size and weight measurements, you're doing those, and those are tied in with the mission. So your size and weight get tied in with each mission, so you want to do that before each mission run. Just some documentation stuff for Explorer class. We want your lift bag documentation. So whatever lift bag release, you have to turn in documentation talking about how you're doing that with some pictures and the description. Your image recognition design. There's some stuff we want you to turn in early for that, just so we can have some of our judges look at your code and your process for doing your image recognition. And of course, documentation, turn in all the SIDs for all the systems you have. Rule changes, we just did that 2 hours ago now, 2.5 hours ago now, so I'm not going to talk about just them, but just a little bit. Remember, propellers need to be shrouded, no circuit breakers, must use a little fuse this year. And again, just, your NRD, your non-ROV devices are this puck, nothing else, so this puck and your release. No other component can use the NRD rules.
Okay, some questions.
Okay.
If you're ready.
Yeah.
For image recognition, are we allowed to use a color filter just to show the shape that's already on the tail, or do we have to put out our own other shape? Or do we have to output our own other shape?
The output that you have on your screen should be, I think it's a colored letter or a colored square or triangle. I think I have to look at the manual again, but no, we need a video overlay of the output we specified in the manual.
Next question, can we use 9-volt batteries as part of the DC system in the control station so that we aren't running 48 through our power switch? This will be an isolated system that just consists of a battery, the switch, and a relay.
What's it doing in the control system? We can't, that can't go down the tether, but a battery to control, what?
Maybe
I would ask that on the FAQ board so we can get a little more information, because I'm not sure what you're doing, but essentially any power going down the tether, 48 volts going down the tether, any conversion has to be done on the ROV. On the surface you can use a laptop that's powered by batteries or plugged into AC, things like that for your control system, but that power is not going down your tether.
So the power will not go down the tether.
I would still say post out. I'm not sure what you're using that 9-volt battery for, so just post it. If it's something really private that you don't want anyone else to know, you can send me a private message, and I'll get to that too.
Top secret.
Yeah, well, you know, so some teams don't want to put out their top secret method. Some are fine with it.
All right, can we run more than one code at the same time? For example, running 3 color filters on 3 different screens.
For your image recognition, you can, I assume that's for image
3
recognition.
different windows, yeah?
You can do whatever you want as long as at the end of it you are displaying that video, whatever the, the overlay, as long as we get that proper overlay. Now, of course, you know, we can't have 6 screens, one with each video, you know, one with a yellow triangle, one with a blue triangle, one with a red triangle. Oh, this is the right one. But, you know, you can do whatever you want as long as whatever screen you're using for that, and we get a video, the video overlay of the proper symbols. Hopefully that answers your question. Yeah. Okay. So I think that's it. Again, if you have questions, want more details, go on the competition help forum, post there. We'll get them answered. We'll get the code for this in a couple days. Got to get Scott home and get him some sleep. But then we'll get that data posted for you, that program posted for you. So that's it for me. I'll turn it back over to Jill to say goodbye.
Yeah, so let's see. I'm just looking to see if anything else. Yes, thank you. They'll post it. Thank you for posting it to the forums board. Yeah, that's it. So in some general questions, this video will live on our Facebook page, our competition Facebook page. It will also, once we get the video file, we'll upload it to our YouTube and Vimeo channels and then link it from the Explorer class webpage. So you'll always be able to access it. And again, as Matt was saying, post more questions to the forums board. That's a great way to put it. We'll get some clarification on the really tricky kind of question we had about if there's an interruption with the transmission and we'll get that worked out. That's it. So thanks everybody. Don't forget to hit subscribe at the bottom. Thank you, Scott, for being here to answer all the wonderful questions. Thank you, Matt. Thank you, Dylan. We'll see you next time. Signing off for today.